In this episode, we are taking one of the most important parts of basic networking and making it easier to understand in plain language. A device can have a good cable, a strong wireless signal, and a working screen, and still fail to reach the internet or talk to other systems if its addressing is wrong. That is why this topic matters so much for brand new learners. When people hear terms like Internet Protocol version 4, IPv4, Internet Protocol version 6, IPv6, subnet, gateway, and DNS, they often feel like networking just became a wall of numbers. It does not have to feel that way. At the A+ level, the real goal is to understand what those settings do, why they matter, and how the wrong setting creates a specific kind of problem that a technician can recognize without turning every support call into a guessing game. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at Cyber.Me in the Bare Metal Study Guide series. The first idea to lock in is that every device on a network needs a way to be identified. If a laptop wants to reach a printer, a phone wants to open a website, or a desktop wants to connect to a file share, the network needs some way to tell those devices apart. That is what an address helps do. An address gives the device a network identity, so traffic can be sent to the right place instead of wandering around with no clear target. This is true whether the network is a small one in a house, a small office, or a larger business. Without the right address, a device may connect to Wi-Fi or plug into a switch and still fail to do anything useful. That is why technicians should think of addressing as basic network identity, because if that identity is wrong, missing, or conflicting with another device, communication starts to fall apart very quickly. IPv4 is the addressing system most beginners see first, and it is still very common in homes and offices. An IPv4 address is made up of 4 number groups separated by periods, and each group helps form the full address the network uses. In many small environments, you will see addresses that start with numbers like 192.168 or 10, because those are common private address spaces used inside local networks. The important point is not to memorize every possible number range right away. The more useful beginner idea is that IPv4 gives devices a practical way to identify one another inside the network and also helps them take part in communication that eventually reaches the internet. When a laptop has a good IPv4 address, it has a clear identity on that local network. When the address is wrong or missing, the device often feels connected on the surface, but not truly alive on the network. IPv6 does the same basic job, but it uses a much larger address space and a different format. Instead of 4 number groups separated by periods, IPv6 addresses are longer and use groups that include both numbers and letters. That longer format exists because the world needs far more addresses than IPv4 can easily provide by itself. For a beginner, it helps to keep the main idea simple. IPv4 and IPv6 are both used to identify devices and help traffic move to the right destination. They are not 2 different versions of networking in the sense that one is normal and the other is strange. They are 2 addressing systems that modern devices may use side by side. If a student understands that both are meant to solve the same core problem of device identity and communication, the topic becomes much less intimidating. One reason beginners get nervous about IPv6 is that the address format looks much harder at first glance. That reaction is normal, but it is more important to understand the role than to stare at the length. A device using IPv6 still needs to know who it is on the network, how to reach other systems, and how to leave the local network when necessary. Those basic needs do not change just because the address format looks different. In real support, you may see a device show both an IPv4 address and an IPv6 address at the same time, and that does not mean anything is wrong. It usually means the network and device can work with both. The beginner lesson here is that you should not panic when you see IPv6. It is not a sign that the network has become advanced and impossible. It is simply another valid way the device may be addressed. Now it helps to connect addressing to the idea of a local network. A device does not need the entire internet to talk to something sitting right beside it on the same small network. If your laptop and printer are part of the same local network, They may be able to talk directly as local neighbors without needing to go out and back through the internet path. This is where the idea of a subnet becomes important. A subnet helps define which devices are part of the same local neighborhood and which ones are somewhere beyond that neighborhood. For beginners, the easiest way to think about it is that the subnet tells the device which destinations are close enough to be reached directly and which ones require help from another device to leave the local area. That one idea is extremely useful because it explains why a device can sometimes reach a local printer and still fail to open a public website. The gateway is the device setting that helps traffic leave the local network when the destination is not nearby. In many small networks, the default gateway is usually the router or the routing function built into the main network device. If your computer wants to open a website on the internet, it does not send that traffic directly to the website first. It usually sends the traffic toward the gateway, which then helps move it beyond the local network. This is why a missing or wrong gateway creates such a specific kind of problem. The device may still talk to some local systems if the address and subnet are correct, but it will struggle to reach anything outside that local neighborhood. For beginners, the simple rule is that the address tells the device who it is, the subnet helps it know what is local, and the gateway helps it know where to send traffic that needs to go farther. Domain name system, DNS, adds another layer. And this is where many users get confused because they do not realize names and addresses are different things. People prefer names because they are easier to remember than long numeric addresses. A user wants to open a website by typing a familiar name, not by remembering a string of numbers. DNS helps translate that name into the address the device needs in order to reach the correct destination. That means a device can have a valid address, a valid subnet, and a valid gateway, yet still seem broken if DNS is missing or wrong. In that situation, the device may still reach destinations if given the exact address directly, but anything that depends on names may fail. A beginner should remember this pattern because it explains a very common kind of support problem where the user says the internet is down, but the more exact truth is that name resolution is what has failed. The idea of a subnet often becomes easier when you picture a group of houses on one street. The houses on that street are nearby neighbors, and local traffic between them can stay in that area. If the destination is somewhere outside that street, you need a route to leave the neighborhood and go somewhere else. On a network, the subnet helps decide whether the destination is local or not. If the subnet setting is wrong, the device starts making bad decisions. It may think a local device is actually remote, or think a remote destination is local and try to reach it the wrong way. That is why subnet mistakes create problems that feel strange and hard to explain at first. The connection is there, the address looks real, but the device is misunderstanding where the destination lives. For A+ learners, the main goal is not deep math. It is understanding that the subnet shapes how the device sees its local neighborhood. Small office and home office, SOHO, networks usually keep addressing simple, and that is a good thing for beginners. In many SOHO environments, one router handles routing, gateway functions, DHCP, and often wireless access all at once. Devices typically receive their addresses automatically instead of having every setting typed in by hand. Common private addressing choices often use ranges such as 192.168.x.x or 10.x.x.x because those are meant for internal use and help keep the local network organized. Most of the time, that automatic approach is the right one for everyday laptops, phones, and tablets. It reduces mistakes and makes the network easier to manage. A beginner technician should be careful about changing address settings manually without a clear reason. Manual changes can solve some special cases, but they also create many avoidable problems when the entered values do not match the rest of the network. Misaddressing is one of the most common causes of network trouble, especially after someone experiments with settings, moves a device from one network to another, or tries to reuse values from an old setup. A device can have an address that is technically valid in format and still be wrong for the network it is currently on. For example, if the local network is using one private range and the device is manually set to a different range, it may fail to talk to nearby systems correctly. The same kind of problem happens if the gateway points to the wrong place or the subnet does not match what the rest of the network expects. To the user, This often looks like unstable or confusing connectivity. Some things may work, some things may not, and the device may seem halfway online. That is a very important beginner clue. Problems that are partial, inconsistent, or strangely selective often point to incorrect addressing rather than complete hardware failure. Duplicate addresses are another problem every beginner should understand, because they create some of the strangest symptoms on a network. A duplicate address happens when two devices try to use the same address at the same time. Since an address is supposed to identify one device clearly, the network gets confused when two systems claim the same identity. The result may be intermittent access, sudden loss of connection, devices that seem to knock each other off the network, or a problem that appears and disappears in a way that feels random. These issues are especially likely when too many manual settings are used carelessly in a small environment, or when someone assigns a fixed address that the automatic system later gives to another device. For beginners, the key lesson is that duplicate addresses rarely create a clean, obvious error for the user. They usually create messy behavior, and messy behavior is often a clue that the network is confused about identity. Missing gateway settings and missing DNS settings can look similar at first, but they are not the same problem, and learning the difference helps a lot. If the gateway is missing or wrong, the device may still reach local systems that are inside the same subnet, while failing to reach outside networks. A shared printer or another nearby machine might still respond, but public websites or remote services will not. If DNS is missing or wrong, the device may still be able to get out to the network in a general sense, but it has trouble turning names into addresses. That means users may say websites will not load, even though the true issue is not always internet access itself. For beginners, this difference is powerful because it helps you ask better questions. Can the device reach anything local? Can it reach the outside world by address? Does the failure happen only when a name must be resolved? Those clues help separate gateway trouble from DNS trouble. Dynamic Host Configuration Protocol, DHCP, plays a major part in SOHO addressing decisions because it is usually the service that hands out addresses and other network settings automatically. When DHCP is working correctly, most users never think about it at all. Their devices join the network, receive an address, receive a gateway, and often receive DNS information without needing any manual work. When DHCP is not working correctly, devices may connect to the network but fail to receive usable settings, which creates the feeling that the connection exists but nothing useful happens after that. Beginners should not think of DHCP as just another technical term to memorize. It is one of the reasons modern networks feel easy to join in the first place. When that automatic setup path breaks, the network starts to feel much more confusing because the device may look connected while still lacking the information it needs to function properly. When you are trying to recognize addressing problems in real support, a simple thought process helps. Start by asking whether the device has an address at all. Then think about whether that address fits the same range as the rest of the local network. After that, ask whether the gateway is present and plausible for that network, and whether DNS is available for name lookups. Then think about whether the problem is total or partial. If nothing works, the issue may be very basic, such as no address or no usable network settings. If local access works, but internet access fails, the gateway becomes more suspicious. If websites fail by name, but some network communication still works, DNS should move higher on your list. This kind of step-by-step thinking is what turns addressing from a wall of numbers into a very practical troubleshooting tool for entry-level technicians. The main takeaway from this lesson is that IPv4, IPv6, subnets, gateways, and SOHO addressing choices all connect to one simple goal: helping devices know who they are, who is local, where to send outside traffic, and how to find named destinations. When those pieces are correct, the network feels smooth and natural to the user. When one of them is wrong, the symptoms are often specific enough to point you in the right direction if you stay calm and think clearly. Misaddressing can make a device only partly work. Duplicate addresses can create strange shared failures. Missing gateway settings can block outside access, and missing DNS settings can make names fail even when some connectivity still exists. If you learn to recognize those patterns early, this topic stops being scary and starts becoming one of the most useful basic tools in beginner network support.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.